Welcome to the Space Economy, your destination for the business of space. We're here with Alexandros from SpaceTalos. George was telling me about your business. And so, one, we want you to tell us your deepest, darkest, most profitable secrets first and foremost. And just remember, it's just going to be between us and a few million people on the internet. So don't worry about it. Two, he was like, radiation in space. I was like, they make the gauntlet where you put the infinity stones. And he was like, not that kind of radiation, Samson.
I'm glad I got you inspired, though.
Yeah. So as we hop into this, because we just like to have conversations with real human beings, because Alexandros is actually responsible for why I can't ship things from America to the UK. We'll get into that later. George, this is a true story. He was supposed to be the science officer for figuring out shipping and logistics for the UK, but he's like, I'm going to go do radiation in space instead. That's a true story. Alexandros, back me up on this and tell us
about it. You got to connect these two. You can't just throw that out there. Connect them. Come on.
I didn't know I was going to be liable for that, but before SpaceTalos, I got a job offer to work for the government for the logistics, and are making a computer model and simulate how the customs and the visa process and all this is going to be after Brexit. But then I started SpaceTalos, so the rest is history, I guess. So
that's why Brexit is broken, because Alexandros was like, SpaceTalos, I'm out. So tell us about what SpaceTalos is, because I was reading about radiation, and literally I did think Xfinity Stone Gauntlet first, but I know it has a little bit more of a profound impact than just being a Thanos weapon.
All right. So the environment in space is quite different and more hostile than being here on Earth, that we're protected by the magnetic field, as you might know. Mm-hmm. So it's an interesting problem, because the first application somebody thinks of is astronauts, right? If we want to send humans in space, we have a problem, we need better suits, how do we protect them? And that's one of the reasons why they cannot stay up there for too long, right? So the astronauts have every few months and then come back down. The reality of it is that it's very harsh environment for everything, and especially electronics, which are very sensitive. Mm-hmm. So not only biological issue, but also you can have issues with your sensors, with your memories, with your processing power, with your telecoms, everything. So this kind of problem can be from something as like simple as accumulated dose, let's say, on your sensor and making it less effective, up to something like very extreme, like a solar flare, for example, that would actually have your system to reboot, or you can have a single event burnout, for example, as they call it in the industry, and you completely lose your satellite. So it's a big deal. So it's an interesting problem. So why we started in SpaceTalos to think about this problem was that people were complaining that the electronics they're using, they're radiation hardened, and qualifying every single component takes a lot of money, like 85,000, and takes years of testing to get it up there and qualified. And we use triple redundancy systems where we have 3 computers doing the same thing pretty much, and then they vote to check that everything is all right. So high reliability application, that's what space is. So that's not very efficient. So the premise around what we're doing is, can we develop a piece of hardware that you put on top, and then you can use whatever you use here on Earth up in space, which means up to 20 years of advancement of your electronics, like that, like a gauntlet move.
So you created a gauntlet for your technology, right? Is that what you're telling
me?
Exactly.
I'm trying to link everything together, all the pieces of the story. It's not easy, so bear with me. But so that's what SpaceTalos is about. We started with something as simple as, can we protect the satellite electronics in space in a better way and more commercial friendly? That's
You're talking about component shielding for satellites, but also for the component parts on the satellite, or is it for the whole satellite, right? So the individual parts protected, or is the whole satellite protected?
So that would depend on the technology effectiveness, because the idea and the secret sauce, if you would like, around this is that instead of trying to block radiation, which at very high energies can be around the radiation belts can be 300 MeV, for example, very high energy protons and electrons going through the material. Instead of trying to block them, which is very difficult, and usually you have what is called a scattering effect. So you stop onto a piece of aluminum, and then you have other particles from behind it hitting your electronics and creating secondary problems or gamma rays. What we're doing is we're not stopping the particle, we're just deflecting it, and we're creating safe zones so that the sensitive component is not affected at all. And that way you don't have secondary radiations as well in this type of issues. So in terms of, obviously the further away you are, the easier it is to protect a specific area and zone. But our aim at this stage is to protect literally on the component level. So pretty much you just put a Talos shielded component and you're good to go. Obviously, depending on the experimental results, we can't go into a PCB level. So it could be a box that it has a system inside and then it works. So plug and play, that's the idea. But yeah, there is a lot of exciting things.
George, one thing, your microphone's a little bit low and we want people to really hear the genius level thing you're about to bore them with. So make sure your microphone is plugged in. There we go. There we go. Excellent. Now wow us with some boring economic fact. Go.
So the importance of computational resources in orbit is something that I've been reading a lot more about. How we have so much data that we are accumulating, but not all that data can efficiently be brought back to Earth for processing, and therefore we want to have more onboard compute. Is this what you're describing, this component shielding, a solution to that? Because obviously onboard compute, they're going to have some really high value parts up there, and we're going to want to protect them.
Yeah, so you're absolutely right. What's happening at the moment is we don't really have real-time onboard processing power, because what we're doing is we're cutting down resources as much as we can. We need to think that when the satellite, your power supply is coming from some solar cells, and so your battery is very limited, and you cannot have a lot of space and volume, so you're quite limited in that sense. So as a result, what we're doing when we are sending the data down, we need to choose what we're going to send. So that it's very complicated, because okay, how much processing do you do on board? Do you have enough power? Are you quick enough? And then if when you're doing all of that, there is a single event and your data becomes corrupted, you have other issues. So with Space Talos technology, what we're doing, we're enabling high performant electronics and components, which could mean that you're actually advancing the RAM, for example, memory systems over 20-year span. There is, for example, the RAD 750, which is the golden standard for RAD hard electronics at the moment, is 20 years old. It's an equivalent of an Intel Pentium 4. To give you just a rough estimate of what's happening in space. So it's pretty amazing if we were able to act as a catalyst and enable all these businesses that they want to do processing on board, smart AI on board, store their data up there, do any type of robotics, visualization, anything that you want to do. It's much easier if you're doing it on the satellite, and at the moment you cannot. So yeah, it's the applications are quite interesting and exciting, I would say, for the future of space.
Mm-hmm. So I have two things, one statement and then one question. There might be two questions actually, because you were talking about the cumulative effects of radiation on this equipment over 20 years. And so I thought of that as radiation rust. I don't know if that's like a real thing, because here in Earth, things rust. So in space, because they're constantly bombarded or exposed to radiation, there's this concept of maybe radiation rust.
Well, it's a little bit, I'm trying to think how to answer this without being too technical. It's not like rust. So there is two effects taking into play, more than two, but I'm going to mention two of them. One of them is the charging effect, which means depending on the material that you have on your satellite, you might have a lot of protons and electrons accumulating on one side, protons on one side, and electrons on the other side, and then you can have a mini thunder inside your satellite. That's one problem that you can have with the charging effect. Usually the industry is dealing with it by picking the right materials and having the satellite in a specific way. The second part is the total ionizing dose, which is what I was referring to before. And it is interesting in the sense, not as a rust per se, but what you're doing is you have a doping effect going into your material, and then it goes into specific areas and creates some kind of deficiency. And then you have these kind of defects over time that they keep growing. And then you need to think that the memory and the transistor, what it is pretty much a gate that goes from 0 to 1. So if you if then you have a change in the charge in there and you get a false positive, false negative, you might have an issue. Also for sensors, you have other issues like they operate on a very specific current. And if you have this type of issues accumulating over time, you might have a different response than the one you would expect. Just roughly trying not to go into too deep of a detail, but
no, I appreciate that.
You know,
I went to public school here in America, so for some of our viewers like myself, I want to make sure that we get it. My other question.
Interestingly enough, sorry to interrupt you. Interestingly enough, one of the interesting problems is not the total ionizing dose, which is one problem. It's the single events. It's pretty much getting bombarded and having high particles coming at a frequency, because they might need you to reboot the whole system. So if you do this often enough, you're pretty much not using your satellite. So
space weather.
Space weather.
Right.
Precisely.
Yeah, we keep on hearing more and more about it, but obviously these space weather events that are episodic, it's a lot harder to plan for because we don't really have any we don't have any good predictive models yet.
Exactly. But when you are close to the South Atlantic anomaly, for example, as you know from the Hubble telescope, you have to reboot all the time because you are closer to the Van Allen belts, the radiation belts. So there is a place in orbit which you cannot go if you are in LEO orbit. If you're in MEO orbit, nobody's going there because radiation is really high, which is pretty much an empty orbit up for grabs. Nobody wants to go there because of radiation. And then if you're in GEO orbit, also you have the same problem. So there is a lot of different environments within the space environment. And my prediction is LEO, okay, it's cheaper and everybody wants to be there because you have faster communications, but has other issues, but it's gonna get cramped really quickly. So at some point we'll need to be able to actually move and do things in different orbits and maybe start thinking about reusing satellites in the graveyard, in the geo graveyard that we have. How are you going to do that? You need processing power, you need robotics, you need the technology and the know-how we have on Earth up on space. So
this also comes to not just a business analogy, but also the strategic high ground, right? So as LEO becomes more and more filled with activity, if you maintain positions in geosynchronous orbit, you're even further out. And so you can then maintain command and control of things that are closer and easier, but then you have the radiation issues that you're trying to solve for. Not to dismiss AI or robots. I love both of them. No hard feelings to our eventual overlords. I'm a fan. But we want to see people outside of LEO. And the radiation effects outside of LEO on folks are not super great, to put that in a very scientific term. And are there solutions? Is this a solution that can work for satellites and for astronauts?
So that's a question that I'm always on the fence whenever I'm getting asked this question, because on one end, yes, you want to, that's the ultimate target, right? Becoming a space nation and space species. Mm-hmm. But on the other hand, as a startup, we need to think in short, mid-term rather than 20, 30 years from now. The technology we have now actually can work so that you don't get mutation of the biological tissue, for example, and protect it against the radiation, but it's at a very small scale. I cannot think for the midterm, my engineering brain cannot say for the midterm if it would work for astronauts. And there is so many things you need to take care of applying it on a satellite and then discussing for an astronaut. It's a whole different game. So I would say possibly yes in the future, but at the time being where we are now, it's not a market for us. So we want to focus on the electronics and enabling modern components in space and electronics. If we can achieve that, it will pretty much revolutionize how we do things. So it's okay, one step at a time.
I love it. So one of my other questions, because I get now that we're talking about this, your first focus is on protecting hardware in space, particularly in LEO. But understanding that in MEO, you have a lot of free space at the moment, and that's where the strategic value is. How do you put a satellite there in MEO and actually have it protected, right? The other part I got from this is, I wrote here in my notes, there's no cloud in space, meaning here we have data centers, but in space, whatever's on the satellite, we have to beam it down because we can't maintain all of that. And so in many respects, the technology that you're developing there at Space Talos is going to enable us to have a cloud in space, meaning the data gets to remain in space longer with greater data integrity. Am I on the right track?
Yeah, it's a possible application, absolutely. And as we go more into machine learning and different other hot buzzwords you hear all around these days, people are more and more interested to do data analysis and do their own calculations and do all sorts of applications that they want, and having cloud server. Yes, that's something that could be possible in the future. Having said that, my engineering brain needs to remind ourselves that in space, we have serious limitations of power and space and volume and mass. So you cannot really take your workstation and just fly it up there. You could, but it's going to cost a lot much more, and you might need a bigger deployment system for the solar panels. But I'm just saying, I'm putting out there is other restrictions in play besides radiation.
My human anthropologist brain does not care about the technical aspects of it. I just want rockets, laser hotels, clouds in space. Because on the business side, we're going to sell that dream, and then we're going to be like, Alexandros, you need to build a hotel in space, and it should have a data center, by the way.
Yep.
So I love it. I love it. George, let's talk about the business. All right, really, Alexandros, let's talk about the business. How are you guys going to monetize this to make money? Because like you said before, it costs about $85K to qualify a piece of hardware, and then you have to add triple redundancy.
Just a component, not even a piece of hardware. We're not talking about a system. Just a component, new component you want. You just have to spend at least $85K. Yeah, that's that tiny little piece. That's it. Yeah. So and it takes years to actually make a new system, a new FPGA, for example, a new microprocessor that you can use in space, and redesigning everything on a hardware level. It's a lot of work. So all the hype is around commercial off-the-shelf electronics in space, and rightly so, because we can drive down the cost and improve the performance at the same time. But it doesn't work always. It doesn't work that well. If you have a high reliability system, it's problematic. After a few years in orbit, you might start considering other options. So you're limited. You're very limited in what you can use. So.
Good to know. Good to know. I don't actually have any other questions at this moment because I'm thinking about this. I will
I know you're one of the finalists for the Spacecom Entrepreneurial Summit. So congrats on that. Obviously, that was back in Q1. Tell me, what other folks have you partnered with? What are your where are your connections in this business, and how you're going to leverage those to get your solution in front of more folks who are looking to improve this?
Yeah, so we've received interest from both small satellite manufacturers at the moment, and in Europe, and some biggest players like primes. But there is skepticism, obviously, because this is space and it's a conservative industry, until we have a benchmark test, which we're going to do later this year, where basically we're going to put into a high energy proton facility, a RAM with a microcontroller and possibly an FPGA that they would not survive otherwise, and shield them and unshield them and see the difference in the results to prove people, and then get ready for an in-orbit demonstration in 2023. I'm receiving a lot of interest. It's quite interesting because there's people asking all sorts of different stuff, because everybody's struggling with this problem, right? With radiation. So I'm getting people who want to protect their passengers on their satellite. So they have a piggy bag and they're putting other people in orbit, and they say, okay, can you protect my passengers as well? Like, I don't want only myself, I want someone else. Someone else is like, okay, can you protect this Pathfinder system? Can you protect this memory unit so that can use a Raspberry Pi for my robot in a lander on the moon or on Mars? So it's very interesting. That's why we're getting excited, because everybody has this problem, and if we can solve it as we're planning to, then we can enable all sorts of businesses. So it's pretty exciting. So to answer your question,
when should we look for the announcement on that test? Is that something coming up in a few months or the end of the year?
So it's gonna be towards Q4 2021, because we are now building the boards for the victim boards that's gonna get attacked, and I think it's a very accurate terminology. And then the tester board, which is going to be the one that's actually going to get the data and say, okay, what's happening here, and send it out. So this is going to take a few months, and then availability of facilities and all that. So we should make an announcement towards Q4 this year. And our plan is to then get letters of intent from companies so that we can, and maybe an agreement for an in-orbit demonstration, because we're planning to fundraise in 2022. So there you go. Potential investors in the US, this is your opportunity. In 2022, we're going to open our fundraising round. So there you go.
Excellent. So he's located in the UK, and they have slightly different testing the water rules. So we're just going to throw that out there. But no, when you're talking, I love the fact that one of my notes is space has a lot of problems to solve. It's like sometimes you just got to state the obvious, because you're telling me something that I didn't know about until we had this conversation, but it makes 100% sense. Earlier, we talked about magnetoplasma dynamics for shield entry to protect vehicles coming and going. But now we're just talking about you're in space. There's a lot of space weather that might be messing with your equipment and degrading its components. So space has a lot of problems to solve. You're solving a problem that everybody encounters, which from a business perspective is great, because it's like you're in space, there's weather, and you have electronics you need to protect. So I love this idea of what you're doing there. I need some more time to digest this. So George, I'm gonna let you wrap us up here as we come to the bottom of the half hour.
Sure. So I think this makes a lot of sense. I see the business use case. I see how this is something that as we push toward more and more onboard compute, we're gonna have to have solutions for this. And I also appreciate that you didn't let me lead you down the other rabbit hole when it came to protecting astronauts, right? Because that's a whole nother question. You know, how long term we can have astronauts past LEO, quite frankly, is a question no one likes to talk about openly, but it is a real question. And so I appreciate your focus on the computational lift. Going forward, you kind of shared with us already your roadmap, the tests toward the end of this year and the fundraising in 2022. Are you currently participating in any grants or any government funding rounds or anything like that?
So far we have received the support from Innovate UK, European Space Agency, from the Business Incubator, the UK Space Agency for a small grant, and the Stage 1 contract from Defense, Ministry of Defense UK. So now going forward, we are applying again for funding, for much funding, basically, because we have our investors on board and get some public funding, or European, from European Space Agency and the European Commission with a consortium for advancing the TRL. But that's that. For me, the speed is of utmost importance. So both me and my co-founder Majid were from academic backgrounds. So my PhD was in computational mechanics, and Majid has 13 years of experience in material physics. So we both felt comfortable enough in writing proposals, but that's not what startup is about. So you need to keep the speed and keep the momentum, and okay, that's fine. If it comes along the way and somebody supports you, it's all right. Otherwise, just keep going.
I love it. I love it.
So Alexandros, most of this conversation went way over my head, but I loved it because now I've got some really good things to research on. So I'm going to think about how I can execute this, particularly when we talk about, I'm going to circle back later, not now, many years in the future, about radiation rust. Because
I hope I didn't bore you to death.
No, you didn't bore me to death. You asked a bunch of questions because you got to protect your equipment, and eventually we'll get to the point to send humans, not just, equipment away from Earth into the far reaches of space. We got to be able to protect humans as well. So your engineering mind is going to protect my human mind and body, and I super appreciate that. And so as we wrap up, tell folks who are listening and who are going to watch this, where can they find you at on the internet?
Yeah, fantastic. So space friends, please reach out at www.spacetalos.com. And you can also reach us on our social media, LinkedIn and Twitter. We're more active. So yeah, reach out with any questions, anything you want, feedback. Happy to engage with the industry. So
awesome.
Thank
you for joining us.
Thank you.
And we will see you all in the next orbit. Bye-bye.
Thank you so much. Thank you for the opportunity.